Hi, my name is Randy Roberts, and I'm going to be sharing some slides with you today. So let me get those up and running. Okay, there we go. Okay, so again, my name is Randy Roberts, and I'll be pitching for our team today on a technology that we think is going to revolutionize how people use satellite imagery. Now, satellite imagery, there's two big problems associated. First off is that satellite imagery has a lot of things in it, typically, and interpreting the image can be a very difficult problem. Second off, quantifying changes in the image is also a very big problem. How do you go in and detect these changes and quantify them, particularly if they're very subtle changes? So we thought we found an intuitive way to interpret imagery. And we also found a way to automatically quantify very subtle changes in the imagery that could be important for commercial operations such as real estate, marketing, and insurance firms. And we call this technology GeoVisipedia. So our value proposition is that GeoVisipedia makes satellite imagery easier to use by simplifying how it's interpreted and also automating change analysis. We think that GeoVisipedia enables businesses and governments to more effectively and more efficiently manage their fixed assets and also to recover from disasters. So there's lots of high resolution satellite imagery that's available these days and provides a natural way to view fixed assets. We can take a look at a building, we can take a look at a structure, we can see what's around it, we can see around how its environment is changing. But the issue is, if we have a complicated picture like this with all these buildings in it, how do we actually make it so that someone could understand where the various buildings are and what do they do? Who are the occupants? What are the floor plans of the building? What kind of leases are on the building? How much does it cost to rent a building? What's at a rate of square foot? How much money per square foot? Okay, so basically, how do we take this complex picture like this and how do we distill it into something that's actually usable to someone? Well, with GeoVisipedia, what we do is we attach a wiki page to each building or each part of a building. And this wiki page can contain all kinds of information such as text, audio, video, sensor data, anything you've got on the building you can put into this wiki page. And again, the key thing is that you can put this wiki page on any portion of a building. So you can have a wiki page for the bottom, for the business at the bottom corner of the building and another wiki page for the penthouse on the building. A simple click and you get all this information. You can add content to it. So as time goes by, you can keep more people can add more content to it. And you can build a full, complete history of the building and what goes on into it. Now, here's the key thing, and this is the key thing for the entire presentation here, is all that information that you collect, all these wiki pages you collect on buildings and this sort of thing in your picture are automatically transferred when a new picture comes along. That's a big deal. That's a key thing of GeoVisipedia. And we also see, we think that there's a latent market for this kind of technology. People that manage fixed assets or have an interest in fixed assets, such as real estate, insurance, utilities, emergency responders, we think they could use this technology to great effect. Another place where satellite imagery comes into play is looking at disasters and trying to get an idea of what happened and what needs to be done. Here we have a picture of a solar farm down in Puerto Rico after a hurricane came through. And you can look at this and say, well, on the right-hand side, it looks like that's a total disaster. On the left-hand side, it looks like some of the solar panels are still in place. And in the middle, there's a mixture of good and bad panels. And all this is all well and good, but what's really needed is a way where you can quantify what this disaster is. So you can go in and count the individual solar panels there, and you can come up with a number that we've got 9,952 solar panels that are total losses, and we need to fix those. Because if we can quantify that kind of information, then we can start to predict how much money it's going to cost to go in and fix it. And also, for example, how much time it's going to take to go in and fix it. So we can get an idea of how long it'll take to get the plant back up online. And so we see the market for this kind of thing, again, quantifying changes in the picture for insurance firms, but also for utilities and local governments, because they've got a very much an interest in this sort of thing, figuring out how long it's going to take to, for example, to get the power back online. So the key aspect of our technology is the PRISM algorithm. And what the PRISM algorithm does, it'll take a model, a three-dimensional model of something on the ground, like a building, for example, and it'll rotate, scale, and translate that model and then project it into the picture. And the projection is very precisely, it overlines the object in the picture very, very precisely. And what this does, this allows us to take and use the picture as an interface to the model. So we put information into the picture, But what we're really doing is attaching it to the model. And so when the satellite comes along from a new direction and we have a new picture from a new point of view, then the model is rotated, scaled, translated, and then pushed down into the image. And so the image basically becomes an interface into the model where we collect all this information. We're able to present this or to project the model very precisely, so we can use this as a shape discriminator and figure out if the shape has changed. And that's a very important thing, because what that does, that allows us to do very, very subtle change detection. So there are some competing technologies in this area, and two that come to mind, one for image interpretation and one for change quantification. So for the image interpretation, the first thing that comes to mind is the Google Earth kinds of technologies. So you go onto Google Earth and you'll see buildings that are three-dimensional, and you see a bunch of dots there that describe the various things that are in the building. But this doesn't really take into account the three-dimensional nature of the building. It appears to on the picture, but it actually doesn't. You can click on one of the markers, and on the top of the building, it will tell you the building's on the third floor. What we do is we take into account the elevation. So if we say something's on the third floor on the northwest corner, that's where it is, and that's where the dot will be, or that's where you'll have access to get to that information. So that's a big thing. And the other thing, again, as I mentioned before, is we can integrate information, and when a new picture comes along, all that information we've integrated and accumulated is transferred onto the new picture. With regards to change quantification, deep learning technologies are very important these days. An example of this is the ArcGIS and their deep learning modules. Deep learning takes a lot of imagery, a lot of labeled data in order to train the neural network. So for example, if we want to detect something very subtle, like for example, we want to find all the houses in an area that are intact, but the chimney's fallen off. What we would have to do with deep learning is to go and to get a lot of pictures of houses that are intact with the chimney and fallen off and use that as a training set. As you can imagine, that could be a very, very difficult training set to get enough imagery to reliably train the neural net. With our technology and with the use of models, we're able to go in and do these kind of very fine subtle detections just based on the model. Because again, we take the model of the house and the chimney and we project it onto the picture. If when we're doing the shape analysis, it turns out that the chimney isn't there, we'll know right away. And so what this does, this gives us an edge when it comes to finding these kind of very rare events. And so we can fine tune our algorithms to detect these very kinds of events. Like let's say we want to find a house that the chimney is standing, but the roof is blown off. We can still do that kind of thing with using our models. We've got a prototype here that we've developed and it's been deployed. And we think that this prototype can be used for demonstrations, and that would be one of our key aspects, what we would do when we get into the business plan. But for now, the thing to keep in mind is that GeoVisipedia integrates customer data with satellite imagery using the model in the back end of it to make this transparency, the way we move information from image to image. And again, we see that this could be very handy for companies like utility companies, real estate, insurance, et cetera. Those people that deal in fixed assets and want to have information on those fixed assets and also see how those assets change over time. So our ask then is for 450K seed funding, and in 10 months, we would do three things. We would first use our prototype that we have and start going out and giving demonstrations to these various industries that I've been talking about. The second thing we would do is develop some strategic partnerships, in particular with the folks that make the satellite pictures that produce that, and also the model builders, because we take the models and the satellite imagery and they feed into our product along with the customer data. And the third thing we would do is hire some business development and some marketing talent, because we're really good at processing satellite imagery, but we're not so good at the business development and market. So we have to hire some talent into that. So now the question becomes, so how do we make money with GeoVisipedia? The thing that's makes most sense to us right off the bat, right out of the box, is to develop a software as a subscription service. And so a customer would come and sign up for us, and the subscription would range for, let's say, between 5 and 10K per customer per year, depending on the amount of service that they require, the amount of support they would require. And so we think by doing that, if we were to sign up a handful of companies, utilities, some insurance, and a few local governments, for example, that we could probably be north of 50K within about a year or so. We think we could really start getting into the big money when we take and port GeoVisipedia and make it into a web-based service. because we think that's where the future is. But that's going to cost a lot of, that's going to cost, take more resources to do that. It will cost some more funding. And what we need to do is to prove it in the marketplace first. So that's why we're starting off with the software as a subscription service, and then moving it into a bigger web-based service later on, if we get the market acceptance that we think we will. So again, our team has a lot of experience, breadth and depth in computer science and working with satellite imagery. We need some help on the business and marketing side, but that will come with the first with the seed funding. And again, we have licensed and deployed GeoVisipedia. It's being used by several national laboratories right now on a national security program. But we think that the time is right because of these things that we can do with GeoVisipedia, make interpretation of satellite imagery very intuitive, and also quantify the change detection. We think that those two things have a lot of commercial potential, and we're very much interested in pursuing that, that opportunity. So thank you, and I look forward to any questions you might have. Thanks. Stop sharing.